Greetings, this is Mrs. Bird from Gettysburg College Advancing Science. Today we're going to be talking about electricity, and we'll be using our snap circuits to practice some skills with electricity. To begin with, though, we have to understand some of the small things about electricity. Atoms are small particles that make up all matter. Small particles? Definitely. Just how small are they? There are more than 30 sextillion atoms in one copper penny. This is 36 tillion. Have you ever seen that number before? I haven't. So an atom is very small. But that small atom actually is made up of 3 smaller particles. And those particles are the proton, which has a positive charge, the neutron, which has no charge or is neutral, and the electron, which has a negative charge. Keep in mind that opposites attract and like charges will repel. And as we go through with electricity, you'll see the difference that having a proton and a negative charged electron will make. Now, electricity is the energy that results from the movement of electrons between one atom to another. Electrons can move in the same direction and produce this electron flow. Both small batteries and very large power sources can move electrons and cause that flow. Now, if we think about electricity as if it were a water hose, sometimes it's nice to use models to simplify things, and this water hose, garden hose, definitely does the trick for that. Let's imagine that a garden hose has been turned on. That pressure, the pressure that is there, even if the water isn't flowing out, if it's stuck behind that spray gun, that is considered voltage if we were thinking of it as electricity, the pressure to push the electrons. So when we talk about electricity, voltage represents that pressure on the electrons. It's the force available to push electrons, just like the pressure in the garden hose. Now, the next term you might hear sometimes with electricity is current. Current is the flow of the electrons. The larger the wire, the more electrons can flow. Again, think about your garden hose. Large garden hose, lots of water coming out. Small garden hose, not so much water coming out. Same thing with current. If you have a very large wire, you can have a flow of a greater amount of electrons than if you have a very small wire. And finally, resistance is what will slow down a current. Think about when you have your garden hose and maybe you step on the hose, or maybe there's some sand clogging it up, or maybe you even bend the hose to slow it down. That's resistance. It's something that will slow down the current. With electricity, it will be slowed down by what's called a resistor. A resistor is something like a doorbell, a light bulb, a fan, anything that's going to slow down that current as it moves through. It will slow down the flow of electrons. Let's take another quick look here. Here's our water pressure, our voltage, same as our battery. Maybe this battery is just a little AAA that we have in our remote control, or maybe this battery is a battery that runs our car. So they're both batteries, they both have voltage. And then we also have our current. Our current flows through the water hose, and here our current of electricity flows through our wires. And one final thing to talk about here are our resistance. Our resistance is what slows down that flow of electricity. In our water hose, it's that sand, or maybe it's your brother or sister stepping on the hose. That's the resistance. In our electricity profile, it's going to be the light bulb. The electrons come through here, go up through our light bulb, come out the other end. It's going to slow down right here. Here's a great schematic to help us remember that. Here's our voltage, our pressure, pushing our current along. Here's our current, and our current is measured in amps. Our voltage, if you see a V, it's measured in volts. And then finally, our resistance. Resistance is measured in ohms, and resistance can vary from very slow or great resistance to less resistance. But again, our pressure, our current trying to flow through, and our resistance right here, measured in ohms. Two other important terms to understand when dealing with electricity are conductors and insulator. A conductor allows electrons and electricity to flow easily, but an insulator resists electric flow so well that no current can flow. Think about when you see a worker from the electric company working. He always has on rubber boots and probably rubber gloves. Those rubber boots and gloves are insulators. They do not allow the electricity to flow through him. Or in your own case, think about the power cord to your hairdryer. The copper wires cut in the middle, they carry the electrons, but the rubber coating on the wire protects us by acting as an insulator. Thank goodness for insulators. Two more important bits of information. An electrical circuit is the route that electrons take to move through conductors. This image shows an open and a closed circuit. So which of these will provide light? The open or the closed circuit? Think about your electrons moving through. First, let's take a look at this one. Here's our voltage. Our electrons flow through our conductor to our light, and it actually passes through and down to here, and it continue on, and we have a closed loop, so the electrons can continue to move. And actually, the electrons are going to move in this direction. So it leaves your battery from the negative end, comes up to the switch, it's closed, so the electrons can transfer through here, up and over, through the light bulb, which is our resistor, back to our battery, which has a positive charge. So our negatively charged electrons are moving towards our positive end. This is a closed circuit. When we turn our light switch on, we actually are closing our circuit. Now, let's go to an open circuit. If you're in your bedroom and you turn your light off, this is what you're going to find. Here's our pressure from our voltage, electrons here, but they get bogged up here. There's nowhere to go. So these electrons have nowhere to go. So these have nowhere to go. So they'll remain inside our voltage chamber here, our battery. The electrons cannot get to the lamp, so it does not turn any power on, and we end up with a light that is off. So an open circuit, no light. A closed circuit, we have our light. Today you'll be using snap circuits, and snap circuits are great little tools to help you understand some different ideas when we're talking about electricity. When I look at this board, I see lots of conductors, lots of insulators, lots of resistors. Can you identify any of them? We have a red fan. That red fan is actually a resistor. It's going to slow down the current. We have a light switch, another resistor. We can make it open or closed also. How about if we removed one of these blue links? Would we have a flow of electricity? No, there would be nowhere for the electrons to travel. They have to have that route. They have to have a circuit to follow. Our battery is going to provide our voltage. And finally, these blue and white conductors, those are the wires that connect all of our different materials together. When you look at your blue and white conductor, try and figure out which one's the conductor and which is the insulator. There's a blue plastic part, and then there's the metal part. Hopefully you understand that the metal part is going to be our conductor, and they provide the path for our electrons. You'll be looking at a few different types of sequences when you build. The one that I have represented here is called a series circuit. There's only one path for the electricity flow. Here's our voltage. Our electrons will flow in this direction, turning on an LED light, coming in this direction, turning on a fan, following this wire along, and we can turn the light switch on and off here, and then back again, and the flow continues to go. If any one of these is removed, we would have an open circuit and we would not have any flow of electrons. There's only one path for our electrons to move here. That's a series circuit. The next circuit we're going to look at is a parallel circuit. And if you think about your homes, would your home work if it was a series circuit? Or would that be just utter chaos? If you decided to turn out your light, everything in the house would go off because all of the electrons would be going through your light switch and it would be open. But let's take a look at a parallel circuit. We have multiple ways for the electrons to flow. Here's our voltage, our pressure. Here's our circuit or our path. And here we have two separate paths for our electrons to move. And that's important when you're trying to set up an effective circuit for your materials. Again, they gather back together. You can switch them off and on. It's your resistor here. This is a resistor. This is a resistor. And back again to our voltage, our battery source, our electricity source here. One very important thing to think about is short circuits. Now, we've often heard of the news report where maybe there's a fire in someone's home, and sometimes it's caused by what's called a short circuit. And that's just when too much current flows through a wire. And it may be that too much current is going through too small of a wire, or maybe there's just no resistance presence to slow it down. Remember, those resistance slow down the current. That's a good thing. So today, as you're working with your snap circuits, it's important that you always follow the instructions in the manual for safety. You may be tempted to go ahead and just try and put some things together, but remember, if you have a circuit like this, the electrons can just flow and flow and flow, and you'll end up with very warm batteries. If you ever feel your batteries and they're warm, right away disconnect something here so that you don't have a short circuit. Sometimes when you are building too, you just don't even realize that maybe you have a short circuit going. So it's best if you just follow the instructions that are provided in your lab manual. There are many, many great activities for you to follow. So if you haven't already worked with snaps at some point, go ahead and read page 5. And it'll give you some great ideas on the proper way to use the different materials in the snap circuits. One thing that I will ask is if you are using the jumper wires, be sure and pull it off by the hard metal part and not the wire. They break easily and they can't be repaired. So just be sure and take your time when doing that. There are single one snap wires, there's 2, there's 3, there's 4, there's 5, there's some with even 6 lengths. So part of the fun is trying to figure out just what number you're supposed to be using. Now there are many, many activities that you can use, but to introduce yourself to the basics of electricity, go ahead and go through these first, looks like 8 different projects, and you'll get a really good idea of just what each part of electricity does and the different components of it. As you're working with it, take a look and think, is that a conductor? Is that an insulator? Is that a resistor? And the fun thing is, if maybe something's not set up exactly right, try and brainstorm and figure it out for yourself. What did I do wrong? Each of the projects will come with your instruction set. As you look at it, make sure you put your resistors in the proper direction. If they're switched, sometimes they won't work at all. If your fan's switched in the wrong direction, your fan is going to fly off. So you'll just have to switch that back. But look for the small numbers and indicators so that they do match perfectly with your project instructions. Okay, so when you're finished with all the pieces, go ahead and return them to their correct location. There is a diagram that will help you figure it out. But most of all, today, enjoy and safely build with your circuits. There'll be lots of things for you to think about, and there's some really great projects. Thanks for joining me today, and enjoy your time. This is Mrs. Bird with Advancing Science.